Hello. All right. I'm just checking how loud I have to speak. As I was introduced, my name is Raphael. Thanks for having me. As you might notice, my co-host is missing because his visa was not accepted. So I will navigate through this alone. I'm currently heading the Cyber Defense Center at Infineon. I'm based in Munich in Germany. And the rest, what this is about, I will try to tell you in the course of the talk. Interesting. Now this is not working. Okay. It was working a minute ago. All right. So kudos also to my other working student who basically worked on migrating what we had to the new Cortex version. Why that needs to be, you will also find out in a few minutes. You probably ask yourself why. Well, I guess this is the wrong group to place that because, I mean, we all know threat intelligence is kind of hot and it's actually not why I did it. When we started looking more into threat intelligence at Infineon, we very quickly faced lots of problems which you might be familiar with. So in general, it's a lot of data from a lot of sources is coming in with varieties of levels of quality. And behind all that is usually a too small team to work with all the data coming in. And in our world, it's the same. My team is kind of small, so it's only 12 people globally. And basically for us, what we try with vetting is ultimately prioritization, right? So basically we want to filter it down to those things which are most important to us, where we see the biggest threats in, and then we want to deal with them first. It does not necessarily mean that we will not deal with the rest as well, but of course, priorities where they belong. So for us, what we are trying to do with our various partners, what we look at it, is it a concern to us? Do we want to deal with it? We might add some additional information which helps the ultimate receiver, which is someone within the IR team, to actually then do something about it. So this basically leads me straight to motivation. In our world, we set up a couple of MISP instances that might seem weird in the beginning because technically we could have used one, but there are several constraints why we need multiple ones. So we have a lot of external partners, a lot of internal partners. We also have a lot of network zones, and to all those reasons we're running like 6 instances, and those 6 instances are basically collecting information from various sources. Some are internal sources like our malware lab, others are partners, and some are only serving to basically serve the threat intelligence we provide to our organization. The problem with that is that makes for a very complex flow of threat intelligence. I don't know, something coming in from the partners need to first be looked at, needs to check whether we have something about the similar thing in another MISP instance, and cross-MISP correlation is not a thing. And then ultimately it needs to go to that instance which is connected to our Hive, where then alerting happens so that someone actually looks at it. And for us, when we started the project, it was not possible with the solutions we found, so it was easier to write something. Right. For the vetting in our world, and I know this is a word lots of people use, that's why I wanted to show you what we do with it, because I think you can basically use it in 10 million forms. So what we are doing, our goal was that we have a central console where I basically see all the threat intelligence MISP events in that case, which came into any of our MISPs, and I only want to look at it once. So someone should look at it once, somehow add information, whether it's relevant to us or not, and this information is added, in our case, in the form of tags, and those tags will then be used to basically route that sort of threat intelligence further. And of course, the ones which is most important to us will always be routed towards the core, so we call this MISP the core MISP. This is the one that is connected to our Hive, and there is basically when then people start to look at it. Of course, there's also threat intelligence coming in where, depending on the course of actions, where something might be blocked automatically. So I'm not talking about that. This is not necessarily vetted. We do that more on a source reputation or whatever. But then there is stuff where someone needs to look at it first, and this is basically happening in that platform. Right. So basically, what we built is a web app consisting of 3 main parts. We have the application as such, we have an aggregation layer, and we have an enrichment engine. For the enrichment engine, a lot of things changed, so we will go into detail for each of those blocks now. So the aggregation layer basically connects to all our MISP instances, fetches all the data periodically. So first, of course, there's a huge batch import, and then it's doing that periodically with some housekeeping. And the idea there is to have basically everything in a very quick store where we can also inter-MISP correlate, and where we can filter through very quickly. You can also, of course, then drill down, so to say, into the single events and always have the related information from other instances at hand. This was a little a challenge in the beginning, but nowadays it's kind of working fine. I will hopefully show you later. For the enrichment engine, when we initially started the project roughly a year ago, maybe it was a little earlier, I don't know, we already used Cortex analyzers to do the main enrichment tasks. Back then, there was no ability to basically centrally configure them, and also there was nothing like rate limiting and all those things which Cortex provides by itself now. So when we built it at first, we built it in a way that Cortex as such was not needed to run, but you could still reuse Cortex analyzers. So not to reinvent the wheel all the time. Nowadays, and this is basically what Joao worked on the last couple of weeks, was basically to transport it back, because now we're using Cortex again, because it makes sense. There is no need to have them in two places. We have all the rate limiting there. So nowadays it's basically interfacing with Cortex again to run all those jobs. We still have Celery in front of it to do some load balancing and things, and to still provide the possibility that you could also write your own modules, but actually it would not be too smart, right? So if one writes something, right, a Cortex analyzer serves both. Right. What we also built into it, and I will also show you that later, is a way that you can basically make chain reactions of analysis. So basically, you start with thumb and you can configure it in a way that it runs until a specific depth to basically reanalyze stuff on the way. When we now talk about the application, you will see it. So it's basically a web application. You log in, you see all the events. All the events you can then filter based on attribute level. You can filter it on event data, whatever you find. In order to do that, our idea, as I mentioned before, was to vet everything only once. So we use our own taxonomy. You can use any taxonomy, and you can use MISP taxonomies to do that. You can basically configure it in a way that if certain tags from a certain taxonomy are applied, that event or that attribute, depending what you choose for the filter level, will not show up in the vetting view anymore. Meaning someone looked at it already and added something and it was basically pushed through, right? What you can do, or the idea behind it, was that maybe the TI analyst doing that might need some additional information to actually make a call on an event or on an attribute level. And in order to do that, he might need to rake in additional data. That data, in our case, is mainly provided by a variety of analyzers, which basically use the MISP attributes as input and then provide their corresponding output. When dealing with that, you sooner or later, of course, strike the problem that in MISP you have data types which are basically joint data types, right? So you have something like domain, pipe, IP, file name, pipe, hash. And for Cortex, this doesn't work very well because basically you need a atomic data type. That's why what we built into it is basically a small regex engine which allows you to either automatically or with a mapping pre-configured or manually to basically split those. So you can basically go, okay, and you can also configure it on a global level, say everything domain, pipe, IP. I want on the domain part those analyzers to be run, and on the IP part I want those analyzers to be run. And of course the analysts can also do that with random text by entering regular expressions and then feeding it to the corresponding analyzers. Once that is done and the analyst comes to a conclusion, in our case we have this, basically it's a very easy scale. It goes from something, we have like irrelevant in it, and we have what legit, and then it goes up to malicious with a variety of things, like maybe legit, maybe malicious, and like this is what the analyst ultimately adds as a tag. And once that tag is added, we decided we want it in a way that if it's added on an attribute level, any given IP, someone looked at it, made up their mind and makes a decision, this decision should be distributed to all the MISPs. So when you basically enter that, it will then be disseminated to all connected instances if you don't choose otherwise. That's important because, I mean, why would you do the work twice? We also built a second mini app into the app, which basically looks a little like a very cheap Maltego. So you have this funny graph, and you can use analyzers to basically go from one node over edges to more nodes, and then you have that nice picture, which eventually helps the analyst to gather his or her thoughts, right? And of course, they can be exported and imported so that they can then be shared amongst analysts or whatever. And all parts of it are exposed via an API so that one can actually script them if needed. Right. Since George is not here, I think there might have been some good fortune in that also, even though of course, it's sad that he's not here. But first we decided to do this live, and there, of course, a lot of things could go wrong. Now, over the weekend, I decided that I will record it. I hope now nothing goes wrong. You never know. It would be double silly if that fails. So basically, as I said, I recorded it. I will play it and comment on it a little. If you have questions, interrupt me or come later. So this is basically the main view. We connected now 2 instances of MISP. One is basically containing lots of OSINT. One is collecting some stuff from our malware lab. This is the initial fetch. So you see how all the events are fetched. See that the upper right hand, when it then suddenly pops to a couple of thousand. Basically, you can quickly scroll through them. And at some point, you can open those events, and you can also open multiple ones. They are lazy loading in the background. So basically, once you click, it's starting to fetch the additional information of that event to make it a little more smooth. And then you basically see all the events. You also see right there if that attribute is found in multiple MISP instances, and those instances do not have a connection amongst each other. Right. This is the thing with recordings, right? So, also I'm talking too quick. Basically here you saw the 2 things. The one is the bulk enrich. It's obviously doing what you're supposed to be doing, or what you think it's doing. And the other one is basically, it can auto enrich a few things depending on a predefined pattern. That's the taxonomy I was talking about, which is basically used to indicate that someone looked at it and decided, whatever the decision was. You now saw that basically there was one of the MISP instances was unticked. So once you click save, it will only go to the ones which are ticked. This is just something we discovered on the way that it might lead to problems if you add it to all the things. And this is now the feature I was talking about earlier, where basically you have that non-atomic file type, which is coming from MISP, which is now, would now be a problem for the Cortex analyzers, which are used to enrich that. So you can also, in case you're lazy, which are most people I assume, or if someone is not so good with regex, you can predefine them so that they can basically, they're auto-completed, and then those data types, they are split, and you can basically apply Cortex analyzers to sub-parts of that data. And then it's doing its enrichment, and once it's done, it will basically return you the way, not as nicely looking as you know it maybe for the Hive users who know it from the Hive. It's a little more ugly, but it serves its purpose. And, I mean, eventually one could make it nicer. Right. And basically you see this little indicator here that, well, stupid video. You saw the little red number there, meaning that one analysis was run. Obviously, if you have those auto enrichment thingies run, once the analyst comes into the event, he will eventually find a lot of attributes with a lot of numbers because a lot of things already happened. Right, I think that was the vetting part, so to say. I don't know how we're in time, but in case you have questions to that, I assume we just do it at the end. We only have 5 minutes left, so moving on. Basically, this now is the second part. It always starts with a white pane. There's nothing. The analyst adds their first node. In that case, it's a domain. It's my domain, so I didn't touch anyone else's domains, even though it's not necessarily legal. What it does now is basically it runs, what I put in as analysis is obviously not very smart, right? You wouldn't do it in that way, but I just want to show how the application works. So I used virus total to extract the IP from a domain, which is, of course, I mean, no one would do it like that, but doesn't matter. So what we basically configure now is a so-called chain reaction. So we assume that from the next stage we get IPs back, as an example, and with those IPs we want to run the corresponding analyzers. And eventually, from that run or one before, we might also get domains back, and with those domains we might run another set of analyzers. And once that runs, you basically see it. I mean, it's a little slow, so maybe we should have thrown more hardware at it, but basically you can guess what it's doing right now, right? So basically it enriches it more and more and more, and that graph grows. And depending whether you made smart choices in the beginning, that helps you more or less. In that case, it doesn't help you at all, beside that you all learn about which domains I own, which is also fine. I was also stupid while recording it, because only later I came to the conclusion that I could press pause and then run further. So you can watch the spinning wheel a while, or you can watch me. I will give you a little the heads up. So basically, of course, this graph is at some point done, and then you can enter on any node, and you can either start from there again, adding new stuff, or you can basically add manual stuff to those, right? So that you say, okay, but for this I know from another source, which might not be connected, I add something manual, and then I start over. We also use this auto extraction feature from Cortex to basically provide more potential observables, which you can then add with one click to the graph, and it will obviously be added as a node with an edge from that node where it's coming from. This is basically when you click, it's added. And then, of course, you can now return to any other item and basically continue like this. In the mean of time, I will basically now skip that part. So also there I was, some API errors happened. Anyways, so I think you get the idea of it, right? Now, why I'm here is, first of all, I wanted to show you this. And second of all, and we can also do that afterwards, my hope was that I get some feedback whether you think this is useful or not. And whether you think we should keep maintaining it, or whether we should just scratch it. Because in the time, of course, other projects also made lots of advancements. Maybe it's not needed anymore. Maybe you can do it in MISP directly. It really depends. I would be really happy if any of you gets in touch with me about what we should do about it or not. I'm also willing to open source it. I'm saying it like this because I know from an enterprise perspective, it will cost me a lot of time to actually open source it, because I need to jump some legal hoops and all the things. But if someone, or at least if it's more than one probably, would say, I'm interested in it, we will definitely find a way to share the code. And if it's more people, I would go through the work and open source it. If you think it's useful, that's it. Right. I think, since I'm a very quick talker, and also I was a little nervous, I think I sticked very well in time, even though we started late. So, thank you all for your attention. Sure. Both. So, of course, for us, what I'm currently doing, and you saw it from the slides, I mean, George was working as a working student for me when he was doing his PhD, his bachelor thesis, and he worked on it. Joao now is another working student, so basically currently I'm kind of maintaining it with working students internally. Once it's open source, that would necessarily have to change, I guess, because, I mean, of course we will still dedicate some work to it, but you know how it goes. Thank you, everyone.